Hello everyone, I am Eber Guzman Cruz. Thank you for coming to my talk. Today I will be talking about oranges and how pasteurization affects its concentration of vitamin C. Before getting started, I want to start off with a little introduction. People consume orange juice because it is so rich in vitamin C or ascorbic acid. Vitamins are organic substances that the human body needs for various cellular functions. It is important to consume vitamins because the human body cannot produce them on their own. The only way to acquire them is by external factors like consuming or eating them in foods. Vitamin C aids in growing and repairing connective tissue, teeth, bones, and cartilage. Its effect can prevent and cure a cold. It is critical that humans receive adequate levels of vitamin C. If vitamin C levels are too high, its effects include intestinal cramps, nausea, and diarrhea. If there's a deficiency of vitamin C, it can put a person more at risk to a disease that can be prevented with adequate vitamin C levels. Symptoms of vitamin C deficiency include painful joints, damaged skin, easy breathing, and oxidative stress. Living a life with a diet rich in citrus fruits and vegetables such as oranges, tomatoes, peppers, strawberries, can help improve or keep vitamin C levels in a human body stable. In fact, pirates would live off lemon juice during their long voyages because of its high concentration of vitamin C. Before they discovered that eating citrus fruits would greatly improve the vitamin C levels, they suffered from scurvy. This is a disease caused by vitamin C deficiency, where gums bleed and previously healed wounds begin to open. A slow death for pirates. Juice undergoes a process called pasteurization. Pasteurization is a process that treats orange juice with heat at a specified temperature for a relatively short period of time. The goal of pasteurization is to terminate any pathogens in the juice that can cause disease and to extend its shelf life. In an article I read by Scientific Daily, it stated that tomatoes lose their vitamin C concentration when they undergo cooking. Many researchers have suggested that foods with vitamin C should be cooked at lower temperatures to preserve the loss of vitamin C. Pasteurization utilizes heat like the cooking of tomato, which brought up the idea if heat used in pasteurization would destroy the concentration of vitamin C in orange juice. Ultimately, it led me to hypothesize that during pasteurization, the concentration of ascorbic acid in orange juice would decrease. Experimental design. 20 oranges were gathered and sliced. Each half was then squeezed through a conical juicer. All the orange juice was strained through a 4-layer cheesecloth. All the orange juice was filled up into 8 50 milliliter centrifuge tubes. The centrifuge tubes were then centrifuged for 50 minutes at max speed. A liquid portion was then transferred into 8 new 50 milliliter centrifuge tubes. 4 tubes were labeled pasteurized and 4 tubes were labeled unpasteurized and then placed in ice. The pasteurized samples were then heated using a water bath. 500 mLs of water were filled up into a 1000 ml beaker and placed on a hot plate. The water was heated up to 80 degrees Celsius. The 4 samples labeled pasteurized were placed into the water for 15 minutes. Once the 15 minutes concluded, the 4 pasteurized samples were removed from the water and placed in ice. I referred to Appendix 3, Steps 1A through 1C in order to complete that assay. The vitamin C assay is used to determine the amount of vitamin C in a sample. The assay consisted of mixing a concentration of orange juice with a specific concentration of the dye DCIP into a curved tube. As the concentration of ascorbic acid increases, you should visually see a color change from blue to clear as the DCIP is decreasing and the DCIP H2 is increased. The change in color will be registered as a decrease in absorbance by the spectrophotometer at 520 nanometers. So what we have here are standard curves. The curves were generated from the data given to us from the vitamin C assay. The curves represent the relationship between vitamin C concentration and absorbance. You might ask why there are two curves. Well, if you look between 0 and 10 and 60 and 100 on the original standard curve, there are plateaus present. The plateaus provide us with inaccurate data. In the curve to the right, we can see that those data points were deleted to represent the most accurate data. Some data points were also deleted to reach the highest R squared value. The closer the value is to 1, the best fit the data is for my standard curve. It represents the most accurate data out of all my data. The R squared value on the right, 0.9977, is much higher than the R squared value on the left, 0.9009, which shows the revised standard curve is much more accurate. So you might ask, what do I need the standard curve? It has nothing to do with my data, but the fact is that it does. Because the standard curve gives you an equation that you will rearrange in order to figure out the concentration of vitamin C in your pasteurized and unpasteurized samples. You first begin by using the equation given to you by the standard curve. You subtract both sides by 1.5412. Then you divide both sides by negative 0.253, which gives you the equation you will utilize to figure out the concentration of vitamin C in your samples. Y stands for the OD 520 value you will use, and X stands for the concentration of vitamin C. So if you want to see an example, you would take the equation given to you by the rearrangement of all the variables. Once you do that, you will plug in your OD 520 value for Y, which will give you the concentration of vitamin C. You would use this to figure out the concentration of vitamin C for all your samples, pasteurized and unpasteurized. So what we have here are my results from my unpasteurized samples and my pasteurized samples. So I got the OD 520s for both samples from the vitamin C assay. Once I got those numbers, I put those numbers into the equation we figured out in the last slide, and that gave me the vitamin C concentration for both the unpasteurized samples and the pasteurized samples. From that, I was able to figure out the average and the standard deviation for both samples. And what I can see from that is that the average of vitamin C concentration is higher in the pasteurized samples than in the unpasteurized samples. So what this shows me is that pasteurization does not have an effect on vitamin C concentration, because after pasteurization, the the pasteurized samples had a higher concentration of vitamin C than the unpasteurized samples. What we have here is a visual representation of the data shown in the previous slide. It is a comparison of the averages of vitamin C concentration in the unpasteurized and pasteurized samples. As we can see, the vitamin C average is higher in the pasteurized samples than it is in the unpasteurized samples. But if you look closely, we can see that the standard deviation between the pasteurized samples and the unpasteurized samples will overlap, which indicates that these two data samples are not statistically different. In other words, it means that vitamin C concentration will not be destroyed during pasteurization. If I were to conduct this lab again, I would actually measure out the 50 mLs of orange juice and insert it into each centrifuge tube. Largely because for this lab, I kind of just filled up the orange juice to the top of the centrifuge tubes, which might have been over 50 mLs of orange juice. I would also switch over to a digital thermometer over an analog thermometer, because digital ones are more precise, but also because analog ones rely too much on the human eye, and the human eye can mistakenly read the temperature, so the whole time your water bath might have been in the wrong temperature. I hypothesized that pasteurization would destroy the concentration of vitamin C in orange juice, but my data did not prove this. Pasteurization does not destroy the concentration of vitamin C. Aside from the tables and graphs seen in the slides before, I went a step further and conducted a t-test with my unpasteurized and pasteurized data. The test attempts to see if these two sets of data are different or not. If the t-test value is higher than 0.05, the null, or the opposite of my hypothesis, is proven. The t-test value for my data was 0.375, which means the null hypothesis is correct. The two sets of data, pasteurized and unpasteurized, are not different. Therefore, pasteurization does not destroy concentration of vitamin C in orange juice. Vitamin C additives introduced in orange juice are not necessary because vitamin C is not lost during pasteurization. Additives are added to improve vitamin C levels in orange juice, but in reality, it is just adding excess vitamin C into orange juice since natural levels are not lost. And we also know that having too much vitamin C in your body can lead to cramping or vomiting. This is not necessary because orange juice naturally has the recommended amount of vitamin C in one serving. Give a special thanks to Dr. Margulas for providing Appendix 3 and Appendix 6. I want to thank Medical Medium for providing the pictures shown in slides 1 and 2. I want to thank the Department of Biological Sciences at Towson University for providing the laboratory manual for this lab. And I want to thank MedMD for providing all the facts and information about vitamin C.